Pete Yost here for the Unbuild It podcast. And hey, if you're attending the PCBC in Anaheim, you got to stop by the Huber booth. Of course, PCBC is the Pacific Coast Builders Conference down in sunny Southern California. It's a great conference, been there many times over the years. The Huber booth is number 213. And the famous, or the world famous Prove It Tour trailer will be at the show. And Steve and I are presenting on Strategy to Process. You can't miss that. So join Huber for a happy hour the afternoon of Wednesday, May 24th at PCBC. It's going to be a great show, especially that happy hour at the Huber booth.
Welcome to the Unbuild It podcast. I'm Jake Bruton, and today, as usual, I'm joined by my co-host, Peter Yost.
Hey.
And my other co-host, or Peter and I's co-host, Steve Basic.
Hi.
And today, we are just going to talk about concrete.
Solid issues.
Sounds
Do you have any idea?
For topics.
He was vibrating with anticipation to get to say that pun. He has been smiling since they started.
What'd you say?
Solid issues.
Sounds like we're hard up for topics.
There's a whole new Steve emerging.
So when we're talking about concrete, the majority of the time we're talking about a structural material that is quite hard and continues to get hard for a long, long time.
Perpetually, I believe.
Yes, I think so. Allegedly. I mean, when they say like it gets
the word allegedly. It's so mocking.
Do your own research. When it gets to the point where they're like, it's at 99.9% at 30 days or whatever it is, or 90 days. And then they go, but it gets harder forever. I'm kind of like, come on. We can just say it's basically done getting hard at like statistically significant hardness. So Pete proposed this idea, and I think at first glance, it's kind of like, well, what does concrete have to do with building science? What does concrete have to do with green building? What does concrete have to do with changing industry standards? So I'm hosting, but I'm going to lean on Pete for this one and say, why are we doing this one, Pete?
Yeah, this is your big idea.
Well,
you wrote it down.
I did write it down. Well, we use an awful lot of the concrete in our business. Portland cement, which is one of the key ingredients, is one of the most environmentally intense products that we make. I think fully 7% of the total carbon dioxide emissions are related to the manufacture of Portland cement. But there's all kinds of things that are interesting about it in terms of why do we choose 4,000 PSI for being the most common, density code book.
Hey, when you say 7%, just because I don't know, that's total concrete Portland cement manufacturer in the country, not just one attributed to residential construction.
It's worldwide production of Portland cement.
Yeah. So when you look at, on a residential scale, it's probably like something of a small percent, because with bridges, roads, highways,
excellent point.
Buildings, like you put up one high rise in downtown Boston, that's all concrete. It's like building like 3 developments of foundations.
Point well taken. However, if there's ever a place to sort of value engineer our concrete, it would be at residential, because it's so over propertied for many of the things that we need it for.
Yes. No, I agree. I'm just looking at it as if we said, okay, let's never build another residential foundation out of concrete. We'll use this material now. How much of that 7% do we challenge?
Yeah.
I don't even know if it shows up on the radar screen. It's a challenge.
It's small compared to, as you said, infrastructure, concrete,
and then on it, but it's just,
and especially the number of really high story concrete buildings that are getting built in China. I mean, there's a heck of a sucking sound there.
So let's just stay on this part of the topic for now. We started with environmental impact. I know what your answer to this is going to be. What's the GWP number for concrete?
The global warming potential for concrete. I have no idea what the global warming potential is for concrete.
I'm hoping you know if you
No, it's an incredibly hard thing to pin down. When you start looking, it varies wildly from batch to batch, place to place, those sorts of things. But the general consensus is bad, not goods.
Bad is in like 100 or bad is in like
tens of thousands sort of thing. But my understanding, because you brought up the Portland cement, when I talk to clients about concrete and when I have conversations with builders that haven't really considered this yet, everybody goes, oh yeah, I could see how concrete would be really bad. Like, I've driven by the rock quarry. I've seen the huge trucks that they're running all day, moving the rocks around. I've seen the crushers. I've seen the guys drilling into concrete to then use explosives. I can see how all that would be really bad for the environment. And then they take it up the hill and they take it to the batch plant. Then the batch plant has all those trucks. And then we have trucks, and then we have delivering it to the job. And then we have pump trucks, and all of that is less than the Portland process.
Yeah, the Portland is the most intense. Yeah.
And the Portland cement process is kind of just turning rocks into lava. Like, that's my understanding, is that like we're just superheating kilns for incredible amounts of time to create the powdery dust that is Portland, that becomes the binder that holds cement together to then make concrete. And so,
and the binder can be something other than Portland cement. There's substitutes that are waste products like blast furnace slag. We talked about rice hulls the other episode. So the problem is that getting people to substitute these materials, which have different properties, that's got to happen at the ready mix plant. And, they're going to have different places to store different binders. You're going to have people who move the concrete who say, we don't like the way these Portland cement substitutes work. So there's a lot of, it's not a one-for-one substitution with
the workability becomes different.
Exactly.
I think the challenge is even before that. It's the perspective of everything that we do and would compare to, we're comparing to concrete. Meaning that, okay, I have a
concrete's the standard
concrete foundation. Okay, that's really strong. It's not going anywhere. We know 100 years from now, we have to get some big machinery to take it apart. So almost anything we suggest is going to sound and look less substantial than the concrete.
It's the same way.
It's always going to be
permanent wood foundation.
It's going to be viewed as a poorer choice, even though we put a wood structure on top of the concrete base and call it a house. Somehow that's okay, but we cannot replace that concrete with anything without suggesting that it's cheaper, it's less durable, it's not as good, with the fact that concrete is probably 100 times stronger than we need whatever to be in a house.
And it's one that we have the ability to engineer to the stresses that it's facing, and we never do. Point in case, 2 foot wide footers, you don't need that depending upon the soil characteristics, but nobody engineers that. It's just like, nope, we put in a 2 foot wide footing because that's the easiest thing to do. We always do it.
I know you haven't seen it, but on the Build Show Network, I actually did a video where I ran through all the calculations of the load that comes down to the 2 foot footing. Cool. And I talk about just that. I'm not going to get into it, but it is there. Go check it out, Build Show Network. But.
So you're making the argument, and I believe you, and I agree with you, that we view concrete the same way that we view steel. When everybody's like, well, it's 4 times stronger than steel. Why is the steel the standard? It becomes concrete is our standard.
Well, it's just a challenge to challenge concrete with anything.
Mm-hmm. Yeah.
Because it is so good at what it does.
Yep.
And what it does is, like I said, might be 10 times more than what we need it to be, but we're not going to substitute it because our perception is that it's cheaper, less durable. It's not as good as concrete.
And when we talk about the building science perspective on concrete, we know that it's a porous material until you get above 7,000 PSI. And then the porosity drops to the point where it's essentially doesn't support wicking. Superior walls, which are the preformed panels, are a perfect example. They don't need to be waterproofed because at that density of concrete, it's no longer supporting capillary movement. So that would be engineered to a specific performance attribute.
But they do it for a different reason. They do it not to build a good wall. They do it because the higher strength concrete, they can remove it and release it from the formwork quicker.
Huh.
So their production rate increases
Well, and it means
significantly.
And it means they can drop in the panels on a non-concrete footer and install them any time of the year that they want, because the only place they have to seal is the butt joints of the individual panels.
How do they treat the seams on those? I've never worked with Superior Wall.
It's a very heavy-duty compressed gasket system.
It's bolted together. I don't know, have you ever seen a bolt on like bulkhead and the gaskets they use there? It's the same technology pretty much.
Yeah.
Okay.
Yeah.
So it's an interior gasket at the butt. It's not a surface treatment.
No.
It spans the whole.
I've never even seen one in person.
Yeah. I mean, they're just big concrete panels that get bolted together.
Yeah.
Sure.
But then the other thing about concrete is, and this constantly came up at Building Science Corporation, was that there is a water cement ratio that is important to observe in terms of the performance properties of concrete. But most companies like to mix it a bit wet because it's easier to move around.
So we call that the actual water that it needs is very little. The water that it needs to transport it in a truck, slosh it around, and place it is substantially more. That water, this is one of my favorite terms ever, is called water of convenience.
Yes.
Because it's not critical water. It's just there for convenience purposes.
And 50% of the total water ends up as bound water in the crystal structure, and about 50% is free water that you have to wait for it to dry out.
Does it count as a drying process, or does it get cured out?
It's a hydration process.
A hydration process. Yeah, so that's not
it's a
technically
dehydration process.
It's a hydration process.
A hydration process. So
it's somewhat counterintuitive the way concrete cures. It doesn't dry out. It hydrates.
Yeah,
it generates heat.
But it builds the available water into a crystal structure, correct? That's the hydration process. So routinely, Joe would say, Joe Steebrook of Building Science Corporation, you've got to make, and water cement ratios are confirmed on the job site with slump tests, which never get done on the residential side, or rarely, but are always done on commercial. But on residential, they get to, make it more watery because it's a lot easier to work with.
Do you want to give us the bird's eye view or the 50,000 foot view of how a slump test works?
I've never had an aerial view of a slump test, so I wouldn't know how to do that.
Oh, goodness. I walked into that one. I'll take blame for that one.
Before. Slump test. Not from 50,000 feet.
You look down on most things, don't you? At
probably.
6'7"?
The gist of the test is literally we form a cone with the concrete that's a measurable size and shape, and then we measure how much it slumps.
Yep.
And how much it slumps has to do with how much water they put in it. You put too much water in it, it's going to flow out and be a pancake, which would be a horrible thing.
And when we had sand layers underneath of our concrete slab work, it was because the folks who do the flat work love to make it a bit soupy because it's easier to push around. And if you have a blotter layer underneath, you get sort of equivalent drying of the concrete down and up, right? And if you put down a moisture barrier there, they hate that because now you have to wait for all that water to come up off the top. So getting folks to put down a plastic continuous layer can be hard with flat work.
It used to be. They used to complain about it. They're pretty much.
They're over
now. They know it's the code.
They know it's there. It's going to happen.
I still think that they tend to run the water cement ratio a little high, so they can move it around more easily.
Well, how I learned to place concrete? Have him put 3 gallons in it. Every time a truck showed up without even looking at it, my dad would say, if you don't know what to do, just tell him to put 3 gallons in it. It's just like, if he puts 3, and it was like, that was his statement. Sometimes we got 2 yards, sometimes we got 4.
But it was always 3 gallons.
It's always 3 gallons. Put 3 gallons in it. It makes it seem like you can hear it. I heard it in the truck, and I can tell it's about 3 gallons shy. So that's the market that I grew up with. Have him put 3 gallons in it.
That's funny. So in terms of I don't know where we're headed specifically with this
We'll
conversation.
go wherever you want to go.
Yeah,
This was your idea.
talk, your big idea.
Well, I can't remember whether we've done an episode strictly on moisture of construction. Have we done that?
I believe so. It doesn't matter.
Okay. But, you know, a 1,000-foot square, 4-inch thick slab gives off about 1,000 pounds of water in the first 6 months. So,
Which is 1,000 pints of water if you're trying to visualize that.
or about 125 gallons of water, and that doesn't count the basement walls. So we're talking about no small amount of concrete that's going to come off. So if you're closing up buildings
Quickly.
not long after the casting of the concrete, that's a load you have to manage.
It's funny you say that. I emailed clients this week about start date for their project. And one of the things was, here's the start date. Here's the first process with the clearing of topsoil. If you have any other plants that you want to move. And then it was, they're going to dig the footings, pour the footings. They'll be back to form. Then after we pour the slab, it may be 3 or 4 weeks before we're back. This is not an accident. We're trying to give the slab some time to cure some of that moisture out because the house is so small. We know it's going to get closed in fairly quickly. Like, it is not an error for us to do that and then wait a month or wait 6 weeks. We have the luxury in our schedule with our type of company that we can do those sorts of things and we can work ahead like that. And I can't imagine, I mean, what is the first 30 days of that 1,000 gallons?
I want to compound that question. Do you think there's a difference in season for curing concrete? Meaning that if I pour that slab in now or in March versus pouring it in, say, end of July, because obviously moisture moves from high to low.
Yeah.
If the air has a very high moisture content, does the slab cure slower than it would now?
You would think the air mass is so great that for that reason it wouldn't necessarily.
Well, that's a really interesting question because if there's a lot of air movement, so let's say there's higher moisture content, but new air is moving in so quickly that doesn't matter. I bet you it has some impact. I don't know how much.
Yeah. I don't know the answer. I'm just thinking.
And it probably is different for a 4-inch slab compared to a 8 or 10-inch wall because, you know, the surface area to volume is different. There was one more point about, so
I just, because it came to mind, I remember sitting in, I don't even think he's alive anymore, but there was an engineer in Boston, Bill LeMeasurer. And he was.
Wait, what was his last name?
LeMeasurer.
LeMeasurer.
Yeah.
As in the measurer?
No.
he was a French measurer.
Yeah. As in like French.
He's the guy that did like City Court building, the Foster, Hancock, Hong Kong Bank, like extreme structural. Like he's the Joe of structural world.
Nice.
And I had the opportunity to sit in on a couple of his project or a couple of his things, and it's standing room only. Same with like Joe. When he talks, the room, it's asshole out.
So he's an expert, but he's also a good speaker.
He's a good speaker, but his projects are just like the extreme.
Yeah.
So I remember seeing this one project where the foundation for the project was something like 100-foot circular footing that it was extremely deep, and it was probably like 100 foot in diameter, but they actually had to run chilled water pipes because the heat of hydration was so high.
Wow.
That they actually had to slow the process down significally
to get it to form,
so it doesn't just like crack apart and stuff.
Yeah.
And now that I'm thinking about it, didn't they do that in the Hoover Dam? Didn't the Hoover Dam have a series of some kind of
having been just been there, I didn't read anything about that, but I have heard.
I heard you scaled it from the out. Is that true? No. Okay. You lied to me, Jake.
Wouldn't be the first time.
But sorry.
Yeah,
but the Hoover Dam had some kind of cooling mechanism because of the amount of concrete that was getting poured.
That would not surprise me. And the engineering of that, those massive thick walls, how they engineered those, there's got to be some cool stories there. And I've heard that the concrete in that dam is still curing. That's pretty cool. Significantly.
That's some damn significance right there.
I swear, this is like the 4th episode or 5th in a row, and you're like taking my place with the puns and the.
I love damn talk.
Welcome to Damn Chat with Steve.
Damn chat.
It's a-
I just
it's a
watched Vegas
spin-off.
Vacation, Vegas Vacation over the weekend. So I don't know if you've ever seen it, but
No.
where he talks about the hydropower from the dam, and the leak at the dam leak.
I have one more question about concrete, which is,
Just one, and this is your episode. You should have hundreds.
well,
But go ahead.
I wanted to ask you in particular because I've never really worked with post-tension slabs, but I know that was a big part of work in areas that have Mount Merlinite clay, the expansive.
Merlinite
Yeah,
clay.
can we have a conversation? You explain what that means? Is that just
I
very,
have no idea what that
very
was.
expansive? Is that
One of the most expensive soils is
It's
the
an
Mount
extreme
Merlinite.
seminary in the mountains.
Well,
of
we
Mount
forget
Merlinite.
his?
You told me you didn't take agronomy, and it's very
His
clear.
agronomy.
Everybody knows Mount Merlinite if you're an agronomist.
Okay.
It's like the expansive clay.
Okay.
But having said that, you have to post-tension the slabs
Yes.
to make them resistant so that they'll sort of float on the
You're
expansive
basically
soil
building a very strong raft
out of concrete.
out of concrete.
And the only way to do that is to reinforce it with cables that run the entire width.
Have you ever seen a slab get jacked?
I've never seen one get tension.
I've had the opportunity to actually see it physically get jacked. Like they're doing it right in front of you.
Cool.
Okay, so if you're not in the South, because that's the only place that I know that they do them, can you explain what a
I
post-tension?
think I saw it up in where the hell? Reno,
Okay.
There
out
are
in Nevada, and the
up
foothills
through
and
the
stuff.
west spine, I guess you would say, of the U.S. There's a lot of expansive soil.
There's a lot of Mount Pillier, Vermont clay. Is that what he called it? I think that's
Merlinite.
I'm kidding.
Montpelier's Vermont.
I know. That was why I said it.
So
A post-tension slab is
essentially has heavy duty cables that are placed during the pour or the casting.
So they're actual sleeves. The one I saw, I believe, and this is like I'm recollecting this from
a long
20
time
years
ago.
ago. But they were like, it almost looked like red PEX pipe, but it was more flexible. And they ran it through, and at the edge of the slab, there's these conical devices that sleeve got pulled through, and they kind of got wedged or formed in the concrete. So once the formwork got
So
pulled off,
the sleeve must be a bond break for the cable to the
Yes.
cast.
Yeah.
Okay.
then they run the cable in.
Okay.
And on one side, there's basically like two half wedges. So they bite the cable and they pull it, and it pulls it into that conical device, which obviously the harder you pull, the more bite you get.
Right.
Then on the jack side, they basically have a jack that they put up against the slab that's literally just jacks the cable out. Then they put the wedges in, and as the cable goes to retract, it pulls the wedge in from that side.
What are the wedges made out of?
They're steel.
They're steel.
And the conical piece is a piece of steel too.
Oh, cool.
So it's your standard kind of like wedge technique, if
Yeah,
you will,
yeah.
right? So they put it around, and it like literally it was seconds. It's like, and then they put the wedges, and then they release it. It goes in. They cut the cable, and it's done.
So in other words,
next
the
one.
slab is poured and then it is tensioned after it is done. So it is a post-tension slab. And therefore, all we're doing is just super hugging the concrete. We're forcing everything to stay
and they
together.
do the same thing. I've been to a precast plant. We have one out. And so like all those I-beams and parking garage pieces,
right.
they do all
Bridges.
the same things. They jack it, and then they...
Because you can get a substantially higher PSI rating, strength rating out of it. Not PSI,
Those
strength
steel
rating.
cables, I can't remember, like the number 270,000 PSI or something in tensile strength. They're extremely strong.
And they're stranded, I imagine.
Yes,
Yeah.
it's amazing. I was just remember reading it and being like how crazy strong they are.
Yeah.
When I heard about post-tension slabs for the first time, I refer to them in my brain as dum-dum moments where it's like I learn about something and I go, yeah, I've never considered that for a second in my entire life, how that works or why it works or anything like that. And now that I know about it, I'm like, why was I a dum-dum and didn't even think about that before? They're not in our market. I'm not probably ever going to do one. I don't need to know about it. But it was one of those moments Where I was just like, they do that completely different in the United States and not too far from me.
Yeah.
In the commercial world too, I don't know if you're aware, but they do, like, raft slab is a term in the commercial world where they'll pour literally like the footprint of a small office building, say it's like 10 stories, and they'll pour the slab like this 6 foot tall slab that's fully reinforced.
6 foot.
Yeah, so the whole building basically rests on this giant concrete raft. It's one, the basement slab, the lowest portion is one giant footing.
Wow.
For the building. And then the building gets constructed from that. Now, the interesting thing is I consulted on a house years ago that the foundation was, I don't know, it was probably a couple hundred feet long, maybe about 250. It was, the house at its widest point was probably about 80 feet, narrowed down to maybe 30 feet in some areas. But because of all the conditions, we put in this very extreme water management system. Then we poured a 12-inch slab that was about 3 feet, 4 foot wider than the house. And then we fully waterproofed that. Then we put the house footing on top of that. And then built the house on top of that and connected the waterproofing from the lower slab over the footing and then poured the new slab up above that.
So you did like a concrete platform?
So the whole house is sitting on this 12-inch raft slab that's basically floating on like 2 feet of stone.
Was this a water mitigation issue?
Yeah, the water. Like they dug down and the guy has, there's 16-inch walls. They go like 16, 17 feet into the ground. He's got a huge media. It's a $30 million house.
Yeah.
Right. So
affordable.
It was an affordable project.
It's like building a boat hull at that point.
Pretty much. And we've done that too, where we've done double walls with double.
Very cool.
Okay. So along your comment about the 6 foot tall slab, one of my other, like I said, dummy moments was I was talking with a, contractor who does some work or used to work in New York City. And he was talking about pouring footings for a skyscraper and how like the pour might be a 24-hour pour or a 2-day pour. They can't have a cold joint. So they'll contract, even though the closest ready mix plant can run it by themselves. They're big enough to be able to run for 36 hours to do the pour. They'll contract with 3 plants so that if one goes down, they still have more trucks coming.
Yeah. But it's like all lit up. They'll have like 4 or 5 pump trucks. Yeah. Like you see some of these outrageous.
But like the cold joint aspect of that, and we have to hire 4 different plants so that there's no chance that we have a cold joint. Like never crossed my mind. It's not my aspect of construction, but I was just like, it makes perfect sense. I would screw it up once and then have to take that skyscraper foundation.
I'm sure somebody did.
Yep, that's how they got there.
Because that's how they got to arriving at those decisions. Certainly.
Well, so a bit of a wrap up to come full circle is that
I'm not ready to wrap up. I got more.
Oh, you do?
Well, I'd like to travel down the z-axis of time.
The z-axis of time.
Yes, when we talk, we're not just talking about the X and Y. I go down the Z.
Okay, what do you got?
So when my last and only trip to Italy with my wife, we actually went and visited the Colosseum in Verona, which is something like 100 years or something older than the Roman Colosseum. It's not as big, but it's older.
Oh, I didn't know that.
Yeah. And literally, like, you can walk all over this place. And just to be in this building to say, like, that stone was mortared in 2,000 plus years ago.
Yeah. Yeah.
And it still looked good. I mean, there were obviously parts of the building where weather was winning the battle. But when you go down inside and there's these, 18-foot chambered, walkways around the Colosseum with these arches and all the stone and stuff, it literally looked like it was mortared last week.
Wow. That is remarkable.
Absolutely incredible to walk around there and knowing that, like, no one's touched that for 2,000 years plus. So, and so that, I think historically, I'm going to bring this around, that's our perception, right?
Yep.
When we walk around and see a building like that, I'll be like, damned if I'm going to substitute concrete for something. Because look what it did here.
Long and hard about that. Yeah, that's interesting.
Like, why do I want to take it out? So I don't know. I think we're stuck with concrete because we're never going to change that perception of durability.
But there are ways to use it a bit more.
Yeah, go back and listen to our episode. I think it's called Building a House Without a Floor, and go back and listen to the Permanent Wood Foundation episode. Mm-hmm. There are alternatives that are perfectly fine. Steve and I have a project upcoming that is going to be Permanent Wood Foundation as well.
I think we do an episode where we talk basement, crawl space, or slab.
We haven't done
or pier.
Or pier.
Well, I think we should talk about it.
I thought we had done foundations from that approach.
I guess we'll find out.
But that could be a potential on the heels of this. Because we might not be able to get rid of concrete, but we might mitigate how we use it and use less of it.
Okay.
Very cool.
So, hey, before we go, I just want to know, did you guys hear the joke about the 2 pizzas?
Nope.
Yeah, I'm not going to tell you. It's too cheesy.
That happened.
He's social media himself into some sort of joke exchange, and that's what
I assume that this all has to do with a bet that he made with a friend from his youth, that he could figure out a way to tell some corny joke on the podcast every time, and we'd let it happen.
I kind of like that story.
You'll never know.
Okay.
Because remember, a secret's a secret.
Call back to conversations we had off the air. That's great.
Well, this was special.
Was that the church lady?
Well, wow.
I think that was the church lady.
The People's Republic of Vermont talking in that voice. I wouldn't even go that far. Wait till you wait.
A moment of...
Okay. All right. You broke the ice. Wait till you hear my joke on the next one.
Okay.
Thanks for listening today. If you are viewing it on YouTube, make sure you subscribe, hit that like button, hit the bell so that you remember, so that it dings you whenever we
smash the subscribe button.
That's why I was pointing at Steve if you're watching us, because I was trying to get him to say it. And leave us a 5-star review on iTunes. That's the algorithm. That's how other people find out about us.
Actually, it was a recommendation from a client. She says, stop saying hit. Like, you got to come up with something like, see, smash the subscribe button. People won't forget smash.
Smother the subscribe button. Thanks for listening.
Bye-bye.
Bye-bye.